My name is Tom Carpenter. I'm Executive Director of an organization called Hanford Challenge. We're a regional organization based here in Seattle. We're a fairly new organization that's dedicated to overseeing a healthy, sustainable cleanup at the Hanford site. And tonight we've invited Dr. Walter Tamosaitis to come and share with us his views, concerns, experiences about one of the most significant facilities in the Northwest and actually in the nation, the waste treatment plant at the Hanford nuclear site. The Hanford nuclear site, of course, is where most of the nation's nuclear waste is stored. And the waste treatment plant is the facility where that waste will be treated, hopefully turned into glass at some point. It's a very technically challenging, expensive proposition. And we rely on insiders to tell us sometimes what's happening within the project because of the pressures externally to get things done on the regulators, on the owners, on the contractors. And it's good to have independent voices sometimes come out and say, here's what's happening, so we can make corrective actions. So I'm not going to stand up here and talk very much longer. I invite you to look at some of the material on the back afterwards. We will have a question and answer at the end. Without any further ado, I'd like to introduce Dr. Tamosaitis.
Okay, thank you. Let me get wired up here. I don't like to stand captive behind the podium, so I may move around a little bit. First thing I want to say is my name is Walter Tamosaitis, and I'm here to talk about Hanford, and Tom led me to believe that there'd only be a few people here. So I have to assume that some of you are in the wrong room. And if you're in the wrong room and you're not here to listen to me with the Hanford description, please, you can get up and leave, and that's okay. I understand. I am Walter Tamosaitis. I am the former Research and Technology Manager and Assistant Deputy Chief Engineer at the Waste Treatment Plant Project in Hanford. The emphasis in that sentence is on the word former, because on July 2nd at about 7:15 in the morning, I was unexpectedly terminated. I'll talk more about that later in the talk. I'm here tonight at the request of the Hanford Challenge to provide some background information on the site and to bring you up to date on what's going on. I think it's very important to be open and direct on what's going on at Hanford because, as Tom indicated, there is a lot of money, a lot of taxpayer money going into the site. A few upfront comments. One comment would be, if you think I'm going to say that the Hanford site is not needed, that the WTP is not needed, or should be shut down, you're not going to hear that. You're not going to hear that at all. The WTP indeed is needed, and I'll give you at least what I consider to be 3 very good reasons why it is needed. My concern, I've titled the talk tonight, A Deep Concern on the Hanford Horizon, the WTP, because I do believe there are a number of design issues, cultural issues, attitudinal issues that are affecting the safety and performance in the plant. At the end, Tom indicated there'll be a question and answer period, and I'll be glad to entertain the questions that I can. Please recognize that there are legal activities underway and some questions I might not be able to answer because of that. A little bit of background. I'm going to use the only 2 acronyms that I hope I will use. Tom said he'll kick me if I use more than 2. One is DOE, which is Department of Energy, and the other is WTP, again, for the Waste Treatment Plant project. The Waste Treatment Plant project is really a phenomenal facility. You could take one of the buildings, the first word I would give, how many people have seen it? Oh, okay. The pre-treatment building, as you know, you could put a football field inside it and play football for those that haven't seen it. I mean, phenomenal. Kickoffs, everything, goalpost. It's the biggest project in our country, possibly the world. It's the biggest cleanup project in our country. It has several, actually many, first-of-a-kind technologies involved in it at almost every step in the process. From the filtration on through to the glass, it's a first of a kind. Nobody else doing it. Savannah River, they talk about vitrifying glass, so what's the big deal with Hanford? Savannah River is an acid-based system. Hanford is a caustic-based vitrification system, so even the melter is different. A lot of first-of-a-kind technologies. The facility, and this starts to get into the design, some of the issues, the facility is built with black cells. Now, black cells, you people have seen, many of the people have seen them, but for the others, it's a room that's sealed up, no lights, you can't go in it after it's sealed up. If you could go in it, the piping is so tight in there, it would be basically impossible to maneuver. It is just really a crammed cell where tanks, pipes, level instruments have to operate for 40 years with no maintenance at all. The plant is built to last 40 years, and that becomes important, to complete its mission in 40 years. Now, the Hanford tanks were built with the mission life. Those tanks have exceeded the mission life, and about a third of them have leaked. I personally don't want to see the WTP reach that point where there's problems later on. With a 40-year mission, or 30-year, whatever it might be, it means jobs and money for Washington, for the state of Washington. I consider that important, especially on the other side of those Star Mountains. The original estimate, the original Bechtel estimate, Bechtel URS estimate, was about $5 billion and was going to take 7 years to construct. The estimate today is over $12 billion, and it's going to take almost 20 and another decade to get the place completely started up. We're going to talk more about that because the $12 billion estimate, there are estimates today that say that that will be over $14 billion. To take today and to imagine you got 10 years to go. And in the first 10 years, the project went from $5 billion to $12 billion, and you got another decade to go. And the Bechtel management says it's not going to go up in price. I mean, a little hard for me to believe that with a decade to go. We'll talk more about that because that concern has DOE looking at alternate studies, including options that could shut down part of the WTP and make it obsolete after billions are spent. The cost for the WTP right now is about 2/3 of $1 billion a year, right at about $700 million a year. When it's up and operating, and this becomes important for later in the talk, the cost estimates are starting to approach $2 billion a year. The system cost to operate, $2 billion. Construction cost, 2/3 of $1 billion, $700 million. If you were going to make a change, you're better off doing it today and shorten it at a year in the future than charging through and taking a year longer when it's built. It's just pure money, just purely where is the money, when do you spend the money. I mentioned that there were reasons why the WTP is important and why I said I am not up here to say it should shut down or stop. I think it's important for 3 reasons. The first reason being the obvious one, the environment in the Northwest. If anything happens to that WTP or to the tanks, or the mission gets extended and something happens to the tanks, it will be a disaster. don't want to see that happen. We got to get that waste out of the tanks and put into a more stable form as quick as we can, period. That's what we got to do. Also, and this one, some of you may disagree with me on this, but this is my view. My view is it's important to show that we can build the plant so that our country can get back into nuclear energy. We have to show that we could build a plant, and by build, I don't mean just build it. I mean show you can do it on schedule, for the cost, and then what's the third item that's important, people? Performance. To build it, even if you build it for the cost and schedule and it doesn't perform well, you haven't proven anything. Performance becomes important. The last item, the third item why it's important, is the amount of money that we in this room and others are spending through our taxpayer dollars. There's a lot of money going into it, and I'm back to a couple of my opening words that it is, to me, important to be open and honest with what is going on. With that much money, our resources going into it. That brings me to the WTP environment and culture. I would classify the culture as a chilling environment. I would classify it as one where if a person continues to bring up issues, they become, it impacts their career, let me say it that way. The plant is not being built with the word robust in mind. I may say this again later, but I personally do not believe the word robust exists in the Bechtel vocabulary at the waste treatment plant. It may exist in other places, but I don't believe it exists there. Where do I start? If I was to start on issues, I'm going to start with one I call a policy issue. And it's really, in my mind, I would classify it as a conflict of interest. And what the conflict of interest is, and I'm sure some of you have heard this or understand it, so bear with me, please. Bechtel is responsible for what is needed in the design. They then get paid for cost and schedule performance. They then decide how it gets done. Now, I'll kind of stop right there. You're determining what needs to be done, how it gets done, you're paid for cost and schedule. It defaults to drive the schedule and get it done. Now you say, well, that might not convince me. Give me another point. Another point is they're not destined to be the operator of the plant. In the contract, the role for starting it up switches to URS. And then if you look, kind of try to read the cards of the future, URS may well be the operator, but Bechtel is not. But back to the terminology, they are the design authority, determining the what. They are the design agent, determining how, and they're paid for cost and schedule. To me, that is inherent conflict of interest from the get-go. If I had to give an analogy to that, I would call it the fox in the hen house. And what I mean by that is the fox is determining what's in the hen house. The fox is going in the hen house. The fox is not just eating the eggs. It's eating the chickens, the rooster, the guard dog. It's eating everything with that conflict of interest. With the emphasis on the cost and schedule, it leads to a chilling environment. If somebody brings up an issue, and it's going to require a design change, you could rest assured that it is not received with open arms. I have seen people in programs, actually in the engineering organization, withdraw from programs because the changes that would be advocated, they would look like they're supporting them, and it would reflect negatively on them. So the people are almost, many people are, I'm going to say, concerned with being associated with a major change. One change which recently was engineered in the plant, we raised it in '03. It dealt with the precipitation of a couple chemicals. I need to be careful I don't get into too many technical details here because I love the plant and the subject. I could very easily get into the oxalate and the phosphate and all the chemicals. But let it suffice to say that we raised an issue in '03 dealing with the precipitation. It took to '09, 6 years, before we could get the attention of engineering to address that. 6 years. We're now making the changes, and there's an argument over whether you go with the lower cost approach or the more robust approach. Let me tell you that the robust approach was put second, despite the group voting for the robust approach. Another example that I would give is what I call the forward jump ball. I find my experience in the culture in the WTP is that an issue comes up and Bechtel URS management used a forward jump ball. And what I mean by that is, here's an issue. I think that light might fall on you. Whoa, I'll move your chair. That's okay, we'll move your chair. What about that light? Oh, okay, wait, we'll move your chair over here. And you keep going to the future, throwing things out there as to where they're going to be done. Now, there's nothing wrong with saying, I'm going to put something out in the future. You can't do everything today. But if the issue gets lost and the details to it are lost, and then you have the turnover over the management. They've had 5 project managers in 8 years, and the last chief engineer stayed there for less than a year, the chief engineer. And they're throwing these things out to the future. The most recent one is the pump out on tanks. The mixing issue, which recently was talked about, it was a issue from a external flow sheet review team back in '06, actually the EFRT. It was called the B&B, the best and brightest. I ran that study, so I was right there. I had 3 assistants. I was the mastermind of that review. Outstanding review, not because of me, but because of the consultants. They brought up the mixing issue, and today the solution, you might argue, is marginally tolerable, but we're going to put pump out in the tanks. We're going to pump out what's called the heel in the tanks. That's the material left in the bottom. Well, I say, well, where are you going to pump it to? Well, we're not sure of that. How many tanks are you going to put in? Don't know. Is it a fixed pump or a portable pump? Well, it could be either. And those issues being thrown out there to the future get lost in detail with the turnover of people. If I had to classify the issues, I'd call it big S and small s. Big S stands for the big safety, the performance of the plant. Technical issues are what add up to be safety issues. My experience, I have over 40 years in the chemical industry, 20 with DuPont, 20 in the, I'll call it the governmental DOE. Any incident that I've seen is not a safety issue, it's a technical issue and a series of technical issues that add up to give a problem. So you could have a number of less than robust solutions for pumping out a tank, pumping out a line, flushing a tank, flushing an ion exchange column. You could have a number of items like that, and each one might just work. But now when you add them up, what you have is an impact on performance, because they're all marginal. So the issues adding up to impact what I call the big S performance are what concern me. Another aspect of it is what I call the small s, and the small s are specific issues. You can take any one issue, and I used the example of the light falling, and we probably could come up with 3, 4 different solutions for how we keep that light up there. And I'm going to use the example of criticality. As you all know, or many of you know, there's plutonium in the tank farm. Plutonium, if enough combines, it can cause a criticality. Criticality would be an uncontrolled reaction that releases energy and heat, and can be, I'm just watching the chairs come in here, releases energy and heat, I'll keep going, and can be dangerous, obviously, to humans. Now, if you said to me, if somebody stood up and said, Walt, are you advocating that there could be criticalities in the plant? I'd say there could be, not a high probability. So we're dealing with a low probability event of high consequence. Now, I had an external reviewer in a discussion say to me, Walt, if you had a criticality, the worst that can happen is it goes poof and it's over. Nobody would know. And I argued with him, and I said, now, I understand that a criticality is self-limiting, goes poof, over. A couple of pulses, yes, sir. But in a $12 billion plant, we shouldn't be debating the design as to whether you could have a criticality. That's the issue. But because of the design, it gets debated. And that's what I call a specific issue with no robustness. You shouldn't be, in my mind, debating the criticality, even if it didn't, quote, didn't matter. But you can imagine the headline in the paper. Criticality occurs, WTP decides to continue operating. Now, you say, well, how do you know? You got to put in criticality alarms. There's all kind of rules and procedures if you could have it. It won't go unnoticed. And if I'm correct, it's a worldwide reportable event. You have to report it to the appropriate international nuclear agencies. I believe that's right. So the thought of having it and then walking away from it and saying, well, it just went poof, there's a lot of concrete there, I don't think it's going to work. And again, it's the point of high probability, heck no. But you don't debate it in a $12 billion plant. I think some of you heard this morning about the push to go to what they call the construction and commissioning phase. We supposedly were in a design construction phase, and Bechtel, URS, are pushing it to go into a construction commissioning phase, implying the design work is behind us, the issues are closed, we don't have to be thinking about them, we're going to drive forward. Now, I ran the best and brightest review. There were 28 issues. There are 11 major, 17 potential. I could go through the numbers, M1, M2, M3, P1, tell you what they are. I lived it. In this morning's paper, it says from the Tri-Cities, I'm sure you all get that over here and read it. DOE closes out 28 VIT plant technical issues. That's the headline. Now, you read it, and first of all, it says they could not reach unanimous agreement that the fixes would be adequate. Okay, we could get by that. The call was made that the issue was closed, but also to do more testing on mixing and to place holds on certain work in the vitrification plant, which would be pretreatment, until testing has provided more confidence in the solutions. So they're going to do more testing, they're going to hold up on the design, But the issue's closed, folks. Don't worry about it. There's other issues from the best and brightest review that are similar, and this is what I call misleading to the public. One of the issues, M6, was process limits. What that issue looked at was you're designing the plant and you're designing it down the middle, the average operation, temperature, pressures, etc., concentrations, whatever it might be. The best and brightest said, well, you know, what if you veer to the edge of your operating range and all your parameters veer over to that edge? What happens? And then if you go 1 degree more, the things go to heck. So the study is, the program is to look at the limits of operation, what's called process limits evaluation. M6 is closed. It's one of the 28 issues. The pre-treatment plant has never been done. Now, that's at least half the work in the process limits, but it's never been done. So it was closed by saying half the work will be done in the future. Again, the forward jump ball. And I submit to you all that if you've got a program and you only do half of it, in my mind, that issue isn't closed. Not till you get through it, because in other programs where we've done the process limits, changes have resulted. But 28 issues closed. I contend that that's not a fair assessment. The mixing issue, which you've read about or heard about, came out of the best and brightest. And at the heart of it is the tri-party agreement. The mixing issue was supposed to be closed December 31st of '09. Bechtel and URS did not make that date. It was then renegotiated, as all the engineers on the project would understand it and believed it, to June 30th of '10, just a couple months ago. Now, there's $6 million in fee riding on it. DOE issued a letter that said it's an all or nothing fee arrangement. So, if you close all parts of it, you get $6 million. You don't close all parts of it, you don't get anything. You could best believe there was a lot of effort and pressure to get that thing closed. And you say, well, what's wrong with that? And I say, you know, what's wrong with that is you didn't have unanimous agreement, and you're going to have to do a bunch more testing. And in fact, it's my understanding that one of the people that disagreed was a DOE person, not even a contractor. So the drive, though, to close the issues for the cost and schedule and that fee profit becomes overwhelming. And again, you say, well, you keep saying that, Walt. You say, now think if you're an engineer and you're going to bring up an issue and your boss has $6 million of fee riding on it. Let me assure you, not very receptive in the management ranks to hear that. Another item that I think is critical in the plant, I was talking to a gentleman before the meeting about this. We're 10 years into the plant, into the project, and the flow sheet is yet to be defined. Now, I saw some eyes glaze over on what is flow sheet. And for some others in the room, that's kind of where the earth starts cooling. The flow sheet provides your basics of your temperatures, your pressures, what material is going through the pipelines, how much is going where, what's liquid, what's a solid, etc. So you're defining what's happening through all your pipes in the plant. Recently, very recently, a few months ago, they identified that the leaching temperature, a critical operating temperature in one of the tanks, was too high. They had to lower it by 15 degrees, 15 degrees C. It was the leaching of the aluminum in the feed. And you say, well, how did that come about? Because there's a very stovepipe design with no systems engineering. So what happened is the process engineers are not talking to the material engineers. Everybody's in their own little world doing anything, because if you raise your head up, you might see another issue and it becomes a problem. So you go down in your hole and you work on your design. So the process engineer said, geez, here's what we're leaching at, 100 degrees C. The material engineer said, oh my gosh, 100 degrees C leaching, 212 degrees Fahrenheit, the tank will crack. It's called caustic cracking in stainless steel. But we can't operate there. We got to lower the temperature. Now, I mentioned the other item about the precipitation. Those changes are just being made. So if you walked in today and said to Bechtel and URS, can you assure me of the safety and performance of this plant? I want an assurance after a decade and nearly $6 billion being spent that this place is safe and will meet the performance. You will not get an affirmative answer to that. They don't know. The flow sheet is yet to be defined. The temperature is just changing. It's just being changed. To me, those are issues. Another issue, I'll go on with a couple more and I don't want to put you all to sleep. We ran a test in what was called a pre-treatment engineering platform, called the PEP, P-E-P. How many people may have seen that? It was over on P&L territory. Phenomenal pilot plant. In that, we found you needed oxalic acid to clean the filter, a form of acid to clean the filter out. The plant does not have the capability to hold in tankage in vessels oxalic acid to the filter. So I personally said to the engineering manager, gosh, you can't handle oxalic acid. And he said, well, sure you can. And I said, how do you do that? How are you going to do that? He says, well, drums. We're going to use drums. Operations can use drums. I said, oh, operations. That's not you. You're not going to be here. No, but operations can do it. I said, this is a 40-year operation. You know you need oxalic acid, a $12 billion plant, headed to $14 billion. You put in a tank in my mind. You don't ask operators to drum oxalic acid. But there's little stuff like that. Another nitty issue is if you had an issue in your mind right now, for those that are familiar with Hanford, and you called up and said, give me the status of this issue. There is no one issue list. You have the peer list, you have the tipper list, you got the risk list, you got the watch list, you got an issues list, you got the managers list, you got the group list, but you got the IRPs, and John, I'm trying to think of the last one, the cut sheets. There are at least 10 different places you go to find an issue. In '09, I suggested one list. I mean, it doesn't take a PhD for that. I mean, one list. Have one list that lists the issues and you can go to. Then subdivide it. But it doesn't exist. Some other examples would be the simulants being used in the waste, especially in the mixing test, and PNNL, Pacific Northwest National Lab, I said I would only use 2 acronyms. Pacific Northwest National Lab raised issues with the simulants being used. The waste is what they call non-Newtonian. Now, let's throw that word out. The waste is like ketchup in peanut butter. Ketchup won't flow under its own weight. It stays in the bottle, and you got to squeeze it. Once you put a force on it, it flows out, then it stops flowing. That's non-Newtonian. If you spill like a drink, a beer, and the beer flows out, that's Newtonian. But non-Newtonian doesn't flow. All the waste is non-Newtonian at Hanford. It's only a question of how much. And if you let that waste sit, it can start to gum up, become cohesive, depending on what's in the waste, how much, how it's been treated, dilution, how much it's been run through pumps. It can become cohesive in nature. PNNL challenged, Pacific Northwest National Lab challenged the simulants that were being used, but time does not permit to go back in the mixing program to develop the better simulant. Another item are just the basic controls. You take the tanks, have these turkey baster in them, the PJMs. Now I'm sure you all have operated turkey basters, and I'm sure when you've done it, you've squeezed it and at the end comes air. Well, in these tanks, you cannot have air come out. The turkey basters cannot let the air come out, because if the air comes out, it's such a shock, a boom, it shocks the tank, and you get tremendous stresses on the tanks. Some of the tanks are only allowed what's called one overblow a year. Now, I see a face back there. How are you going to control one overblow a year? How do you even measure it and know it happened? And these tanks are in black cells. So the whole control scheme of measuring the level, the overblow, the PJM control is another item that's got to be looked at. But you don't hear it being talked about. There are no design issues, or let me reword it, the design issues are behind us. We're moving into construction and commissioning. I contend that that's not an appropriate description. Another one is the air system. Now here's one for you. We're going to have a little group test. If I said we're going to operate I have a water hose here, and water's coming out of the hose, and I want to operate this hose 24/7. What does that mean as far as water's coming out of the hose 24/7? Boy, I could see people saying, you're not going to stick me with this.
Well, the water has to go somewhere.
Okay? Most people would think it means 24 hours a day, 7 days a week, water's coming out of the hose 24/7. Now, when you go to that's what the process engineers think. When you go to the mechanical designers said, oh, 24/7 means only 15 minutes every 24/7. So it's only every 15 minutes, every hour for 24 hours a day. That's 24/7. Now, the issue, you say, well, they could define that. You're right. It's easy to get together, define what it is. The issue is the air system. The air system does not have the capability to power the PJMs and the system the way it needs to be powered. So they're looking at, remember my word robust? Less than robust solutions. Now, when they don't mix the tanks, think back to the cohesiveness. That way settles. Now think the technical issues. So now you got an air system, doesn't have quite the capability. Waste is settling. Things begin to gum up. And what do you have? A big S problem. And now you're shut down. Now you're cleaning out. And now you have problems. Oh, guys, I'm going to get hit. Turkey baster, pulse jet mixer. It's a long tube with air that sucks material, the fluid up in it, just like a turkey baster.
Up from the storage tanks.
In the tank it's in.
Yeah.
In the tank it's in. Sucks the material up in it, and then the air pressurizes and pushes that fluid out. But you got to stop pushing that fluid out before the air comes out. So now you have to control with different tank levels, different density materials, different solids, different temperatures, different air pressures. You got to control this and not ever let the air come out, or very seldom let the air come out. Phenomenal control issue. But the design issue's been done. Yes, sir?
Have you mentioned your concern about the filters, both cleaning them and what's left behind in some of the filters?
Have I mentioned it here or at
Yeah,
work?
tonight, here.
No, I have not mentioned it here. There's a number of issues that I could go through, and I haven't. We did put that, I get to it in a few minutes in a general sense, in that we had alternate filter cleaning techniques and filter optimization studies on the list of 50 that got me fired from Bechtel and URS. But I'll talk about it there. Good question. Now, I mentioned earlier on that DOE has chartered studies, actually URS is one company that's doing them, is looking at alternate flow sheets. And why are they looking at alternate flow sheets? Because the cost to operate the WTP and the confidence in that it will perform is raising, let me reword it, giving a lot of stomach acid and raising a lot of questions. So they're looking at, have studies underway to look at alternate waste forms, low-level waste forms, alternate pre-treatment schemes, including in the tank farm. I said to one manager that, you know, if you do that, what about the billions that are not used? If the LAW plan isn't used, what about those billions of money, dollars? And I was told, the man said to me, we don't count that. That money's gone. And I say, man, that somewhere in there it's misleading to be just looking at programs that way. So what happened to me? And I'll touch on the filters here very briefly. My group had plans to move with our money and scope. Actually, John Truex, sitting here, was one of the members in the group. And we had money and scope to move to operations with work and scope to last 2-3 years. Actually, an organizational announcement had been typed up, and it said Walt and his group are going here. That's on June 30th. On July 1st, we had a meeting. The meeting was actually prompted by Bechtel management to identify technical issues. They wanted to bubble the issues up, put the list together. So my group put together a list of about 50 issues. I think it was 45, and a little bit depends quite on how you group and count them, but 45, 50 issues. Not all of them are new. Not all of them were new. Some had been talked about, but they were 50 open issues. We also included on the list 100 from the year before. It was a couple more than 100, but I'll call it 100 using management windage. 100 issues. Some of those were closed, but we left them on the list. We didn't go through the trouble editing them. In that meeting, a discussion came up on a process hazards review, which is a very detailed review. Let it suffice to say it's a very detailed review of every step of the process. I concurred with doing that. On the list of issues, I reinforced the need in one of the columns on a large-scale demo, large-scale test to demonstrate that a vessel with the sampling, the level control, and so on would work. Because as somebody pointed out to me, they had been to MCE and the testing was being done in 4-foot diameter plastic tanks. So there was also the thought in my mind that I did not support, this is my opinion, did not support the M3 closure. And in fact, I was not one of the approvers, one of the decision makers on that issue, on the M3 issue. I was willing, while the mixing was marginal in my mind, I was willing to live with it for 2 reasons. One reason is I'd been told by URS management that there was going to be a large-scale demo. The second reason was I was going to be there. And if my group is there and I'm there, we'll wave the flag to make sure these issues continue to get raised up. That was the issues meeting. I'm scheduled to come in on July 2nd, Friday morning, for a 7 o'clock meeting with the operations manager to talk about the last little details of my group being moved. And little details, I mean, how many admins you're going to need, who gets a cubicle, who gets a window, are we going to move our offices, do we stay where we are, items like that, logistics. I had one of my managers with me. The operations manager, a URS manager actually, came out and told the fellow that was with me, you need to leave immediately, the meeting has changed. And we said, geez, what's going on? He said, meeting's changed, you'll find out in a second. Get in the office. So I go in and sit down, and there's an HR person there. And I said, well, at first I didn't think much of it. I thought, well, the HR person's here because we were having a discussion about the group move, and maybe there's papers to sign. They want to know what's going on. Well, the next word out of the URS operations manager's mouth is, give me your badge, give me your cell phone, give me your BlackBerry, and you got to get off the site immediately. Huh? What happened? Why? Bechtel Management wants you off the project immediately. How come? Don't know. Why? Can't give you any reasons. I go back and forth between the two people. Can't be told, don't know, can't tell you anything. I said, can I go back to my office to get some personal things? No, you can't go back to your office, no personal things. We'll pack them up and ship them to you, which I've only got a few items, but anyway. I said, look, I owe about $30 to a person, one of the admins that was sitting out front. Her daughter was going to babysit our Scotty that weekend. And I had told her when I went in, I'm going to come by and pay you so you can give Stacy the money. I said, could I go by and pay such and so Stacy can have her 30 bucks? Nope, you can't see anybody. You got to get out. We'll escort you out. Give me again your badge, your phone, your BlackBerry. You'll be escorted out by him, and you've got to leave the Hanford site immediately. And that was Friday morning, July 2nd, and the last day I was on the WTP project. To this day, I don't know why. I've been given no reason. I've asked numerous times, have not received any reason, verbal or written, as to why that happened. When I look back, what I submit happened is where I started this presentation with the culture. Those that were here this morning heard about wanting to go and send a message of going from the design construct to the construct commission. And here's a person who says, you know, there's some issues. There's filter issues, there's nitric acid issues, there's issues on oxalic acid, there's a number of things that need to be done. The last thing the Bechtel and the URS management wanted was somebody raising issues when they're trying to drive forward. That's the best, in my mind, I can piece together as to what happened. So what do? You eliminate the potential obstacle and you're out of here. So, I looked at the facts, I looked back, and what I had always told my people is you do the right thing. People, if you got a program to do, you ask, what's the right thing to do? Now, you may not choose to do the optimum right thing for any number of reasons. So the second question becomes, if you're not going to do what you think is optimally right, are you willing to stand up and tell everybody and explain it? Now, if you're not willing to do that, then you got a problem. There's something not right. So I've told my people, that's what I tell the young engineers, the summer students, even some of the older engineers, that that's what you do, the way you manage your programs. That, to me, is professionally ethical. So when I went back and looked at what happened, I sat down. I forgot to introduce my lovely wife back here, Sandra. We sat down. Raise your hand, wave, honey. I forgot. I'm sorry. I get a performance review later on this one. And we God, I hope there's another hotel room. And we sat down and talked, and I came to the conclusion what they did was not right. It just wasn't right. You don't take somebody of 41 years with what I've done, or even somebody, I'm going to say somebody who has 20 years, 10 years, and treat them as if they're put in handcuffs and run off the site as if they're a felon. You don't do that. Not in my professional opinion. So, I wrote a letter to the Defense Board, and I said at the beginning of the talk that this is not about me, because that one letter has prompted more response than I could ever imagine. Just reinforces me that there's a higher power that's helping to guide everything.
What's the Defense Board?
Defense Nuclear Facility Defense Board. They are chartered by Congress to provide the nuclear oversight of the Department of Energy. They're appointed by the President, approved by Congress, and they provide the oversight similar to the Atomic Energy? NRC, excuse me, NRC, yes, NRC over commercial. I'm sorry. And that letter has prompted more response. I have had, and my wife can verify this, we have had more phone calls, emails, letters, strangers coming up to the door. Are you Walt Tamosaitis? Yes, I am. I want to give you some information. I'm willing to tell people to call me. I mean, the response has been overwhelming. And it is an intense effort to take on, so the response is encouraging and helpful as I take on what I think was not right. Okay, coming to the end. How am I doing on time? Okay. You can't stand up here and go through something like this and not have recommendations. Just as I told my people, that just to have a complaint and complain about something, that's not being professional. If you're going to complain about something, have a recommendation. Have a recommendation as to what you can do. So I'm going to do it here. There's systemic and there's specific things that can be done. The first one, which I consider to be systemic, is they've got to separate the design authority and the design agent. Got to separate that Bechtel is not both. Now, if it's Parsons, it can't be both. If it's URS, it can't be both. But to me, as I said earlier, that's the fox in the hen house. I mean, and if it continues, the fox is not only eating the eggs, the rooster, the dog, it's going to eat the hen house. It's such a conflict of interest, it just bamboozles me. The second item would be the Pacific Northwest National Lab. Their involvement has kind of cycled over the years for a number of reasons. Their involvement should be increased. We need to change the chilling environment. People need to be able to speak up. They should not look, and I should not be an example to the people on how a person should not be treated. This is not an example that should be out there for people. And lastly, we need to examine if we cannot change the chilling environment and separate the how from the what, we need to look at whether the right contractors are there. They may not be the right contractors to effect the change that's needed. Now, more specifically, I mentioned earlier that the cost to build the plant is in the range of $700 million a year. To operate it, the system cost when they go to operate is like $2 billion. I would encourage that a good look be taken today with mission in mind. Go back to that '06 study by the best and brightest, and they said there was lack of mission focus. Take the time out today to look at the plant, and you don't have to stop everything, but pre-treatment is one place where you would certainly take a damn good look as to whether it's robust and meets the mission focus. This includes, I think the fellow left, but the filters, filter cleaning, etc. in the operation. In DuPont, in my 20 years at DuPont, my last job was plant manager in DuPont. We at their Old Hickory chemical plant. We started up a new DMT process. It's an acronym. I won't even go into what it is. It's a polyester intermediate. It took 3 years to get the plant to even approach a 50% production rate when it started up. Now you say, 3 years might not be bad. 3 years out of an operation life of 40, that's 10%. That ain't bad. But in that plant, you could walk out and touch everything. It's not a nuclear plant. You can't go out there and just grab the pump and see if it's vibrating. You can't just run out and change a pipe gasket. So the startup of the waste treatment plant, the WTP, in my opinion, based on my DuPont experience, is going to be damn difficult. You can't run out there, and it's not a nuclear reactor. It's a chemical plant. And I should have said that in the beginning. Many people think it's a nuclear reactor, a commercial nuke plant. It is not. It's a chemical plant. When the weather changes, the operation is liable to change. And that's no lie. And people look at me and say, now how in the heck is that going to happen, Walt? In DuPont, we may not have had the best insulation, but when it rained, the steam lines cooled. You dropped the steam pressure. Pressure dropped, temperature dropped, distillation columns went into an upset. So it's a chemical plant. It is not a nuclear reactor. It just happens to have radionuclides in it. We need to have a systems engineering review. Now, many people say to me, what's a systems engineering review? I'll make it quick. Systems engineering is the door hinge on the door. The stovepipe in engineering would design the door. They design the wall. They hang the door on the wall, on the door jamb, on the frame. The systems engineer examines the door hinge and does the door work well with the wall? Will it last 40 years? Is it strong enough? Is the wall strong enough? Is the door, the bolts strong enough? Systems engineering looks at the interface. The interface would have prevented the temperature problem that I talked about earlier, going from 100 to 85 degrees C, changing the operation. That change results in more high-level canisters made. So it's not inconsequential. You make a change in a chemical plant, and you have changed the product. There's some other items. I could go on with pipeline flow. Bechtel and URS contracted the Pacific Northwest National Lab to look at pipeline flow and whether we had the right velocity in the pipelines to keep stuff from settling out like in a sewer pipe. Bechtel, URS decided not to accept the reports. The reason for that is the calculations would indicate you needed to make piping changes, pumping changes. You can't just take and change the pump without changing the pipe, because the higher flow creates more pressure drop, and then you have a problem. So it's a system. Again, we're back to the systems engineering. I mentioned the air system. That is another true story. In the high-level VIT plant, back in '03, when we were working on the turkey basters, the PJMs to mix the tanks, we decided that the turkey basters by themselves could not really mix the material well enough because it was like peanut butter in the VIT plant. It's got the glass formers in and it's much, much thicker. Actually like peanut butter, really. So we were going to put sparging tubes in and sparge air and have, like in a fish tank where you have an air line going down and air is bubbling out, and the bubbling air would help mix the tank. So we had the turkey basters at the bottom and spargers at the top. The VIT plant ventilation was so tight, so tightly designed, literally you could not connect another bathroom fan into it. An exhaust fan, you know, like you have in your bathroom you turn on, it would not take even a minimal amount of air. So what was the solution? They eliminated the tank. Now you say, what's wrong with that? Well, in a chemical plant, you don't eliminate tanks, valves, stubbins, because you're going to need them in the future. You need the flexibility. Somewhere something will leak and you're going to say, where can I accumulate this material? But the tank got eliminated. So now I offer to you, remember my word robust, that ain't very robust to eliminate the tank. But it eliminated the problem for them. No tank, no mixing problem. I mean, it's pretty straightforward. What are the 5 things, or what are the things I would hope would come out of my effort? There are 5 things that I'd like to see come out of it. The first one is I want to see the WTP plant start up and run well. I don't want to see it limp along. I don't want to hear as the current Bechtel manager says, we'll fix it at startup. We're going to leave a port in the wall in this black cell, and what we're going to do at startup is, if we have a problem, we'll go in there and modify the tank. Heck, you can't even see the tank, let alone get in there. You may as well just build a new part of the plant. It's so complicated in there in the piping. So I'd like to see it start up and run well. I'd like to see it start up sooner rather than later. And I'd like to see it complete its mission sooner rather than later. But that requires performance. Not just cost and schedule, but operating performance. I'd like to see the young people, now this is really important to me, and I'll try not to get emotional on it, but I would like to see the young people look and say, you know, what they did to Walt was wrong. That's not the way you manage. And by golly, there were corrections made. That's important to me. I don't want them to think, the young people coming up who are our next generation, now back to the nuclear renaissance, who will be running the reactors, future plants, that the way I was treated is the way you manage. That's important to me. I want to see the culture changed from chilling and punitive to open and receptive. Now, again, that may require a change of the contractors that are there. I don't know, but I would like to see that culture change. And lastly, I'd like to see a message sent to the contractors that more than the contractors at Hanford hear about it, know about it, and it may affect how others think. So I really want to see, my hope is that it will have an impact, make WTP more successful, make it start up sooner, make it run well, and people will know what's the proper way to manage. In the beginning, I said I chose the title of the deep concern on the Hanford horizon, the WTP, with a lot of thought in mind. And I really did. If you follow some of the reports, there was one by Lloyd's Register that about a month before the incident in the Gulf identified the chilling environment. You hear about the gasket that was tore up and nobody took the time to look into it and fix it. They had schedule pressure. What did they do? They chose to only put 2 shots of concrete in it rather than 3 because they could bring it back online quicker with only 2 shots in it. There's also some issues as to whether the concrete was the right mix. Now, what you hear, and what I heard on the news this morning, are the number of design and construction issues that led to that environmental disaster. You know what I did not hear? And 11 people died, right? I did not hear him say it was a safety issue. All those little issues added up to create a problem. So the technical issues are what got to be addressed, or it won't run well, and at some time in the future, something bad's going to happen. Now, in DuPont, we had a saying, and that was that operating a chemical plant is like flying an airplane. It's a lifetime of boredom and a couple moments of sheer thrill, if you will, excitement. I have been in DuPont plants where I've seen a tank truck blow up, blow the building apart, person get burned pretty bad with a polyester intermediate chemical, was not wearing his flame suit, his heat resistant suit, but seen a truck blow up. I was at the Sabine River Works where we had a fire in the cyclohexane distillation building. Now, for those that know anything, follow the chemical world, does anybody know about Flixborough, England? It was a cyclohexane plant that blew up. I encourage you, for the technical types, go onto the web, type in Flixborough, and look at what happened. That was the same incident at Sabine, but luckily, nothing blew up. But we had a fire in the midst of the main building. In that fire, I saw a person scale an 8-foot barbed wire fence and go over it. That's what you call somebody being panicked.
Motivated.
That's motivated, yeah. He was motoring. Norbert Micklitz, I remember his name. That's the impression it made. But I've seen that happen, and those issues didn't result because we had a safety issue in the distillation building. There were a number of technical issues that add up, and then Mother Nature has some effect, whatever that might be, the unknown, what you don't know, and you have a hell of a problem. That's what I want to see not happen in WTP. But I want to see it run well too. Run well, no incidents. So, with that, I've probably overextended my stay, and I'll say that concludes my talk. I'll be glad to entertain questions for a period of time. I've probably overrun the period, or overrun the time. I thank you all for staying awake. I was looking around the room and I don't see any shut eyes, and that's the first time it's ever happened to me. So thank you very much.